Visit Chandra's beautiful universe. GW 170817. On August 17, 2017, scientists using gravitational wave detectors in the United States and Europe picked up a new signal. This object, which became known as GW 170817, became the first time that gravitational waves and electromagnetic radiation, or light, were seen from the same source. Astronomers soon classified the burst of light as a kilonova, resulting from the merger of some of the densest objects in the universe. There were many telescopes that observed light from GW 170817 in the hours and days immediately after the gravitational waves were detected. Most of those signals have faded away. NASA's Chandra X-ray Observatory is the only observatory still able to detect light from this extraordinary cosmic collision more than 4 years after the original event. What have astronomers seen in the Chandra data? Right after the initial LIGO detection was announced, scientists requested that Chandra quickly pivot from its current target to GW 170817. At first, they did not see any X-rays from this source, but about 9 days later, Chandra looked again and found a point source of X-rays. This non-detection of X-rays, quickly followed by a detection, provides evidence for a narrow jet of high-energy particles produced by the neutron star merger. The jet is off-axis, that is, not pointing directly toward Earth. Researchers think that Chandra originally viewed the narrow jet from its side and therefore saw no X-rays immediately after the gravitational waves were detected. However, as time passed, the material in the jet slowed down and widened as it slammed into surrounding material. This caused the cone of the jet to begin to expand more into Chandra's direct line of sight, and X-ray emission was detected. Since early 2018, the X-ray emission caused by the jet had steadily been getting fainter as the jet further slowed down and expanded. Researchers then noticed that from March 2020 until the end of 2020, the decline stopped and the X-ray emission was approximately constant in brightness. The fact that the X-rays stopped fading quickly was the best evidence yet that something, in addition to a jet, is being detected in X-rays in this source. In fact, the scientists had to identify a completely different source of X-rays to explain what they were seeing. A leading explanation for this new source of X-rays is that the expanding debris from the merger has generated a shock, like the sonic boom from a supersonic plane. The emission produced by material heated by the shock is called a kilonova afterglow. An alternative explanation is that the X-rays come from material falling toward a black hole that formed after the neutron stars merged. To distinguish between the two explanations, astronomers will keep monitoring GW 170817 in X-rays and radio waves. If it is a kilonova afterglow, the radio emission is expected to get brighter over time and be detected again in the next few months or years. If the explanation involves matter falling onto a newly formed black hole, then the X-ray output should stay steady or decline rapidly, and no radio emission will be detected over time. Astronomers will continue to monitor GW 170817 with Chandra and other telescopes to see what new secrets this object may reveal.